Hey guys, this is Mothman Engineering. I wanted to explain to you guys how to complete the square now, especially since I just taught you guys how to foil in the last video. If you haven't seen that, you should check it out. There should be a prompt popping up right now, somewhere up here. But I figure that since I taught you guys how to foil, I should teach you guys how to get zeros for an equation, or aka those two numbers inside of parentheses. Those are going to be very important for you in pre-calc. I'll teach you guys about that in the next video. But for now, this is going to be the main way. I'll show you guys how to do this. I'll teach you guys the other, I believe there's 3 other ways to factor an equation, but I'll teach you guys that later, and I'll teach you guys more ways to open up equations than just foiling, because sometimes you'll have more than just, a minus x to the power 2 and stuff like that. But for now, this is my favorite way to break it down, and this is, a lot of people see it as the most difficult way, when it's really not. It's much easier, and it takes a lot less thinking. It's just plug and play, do whatever you want. So the first concept that I want you guys to understand is that this is the function of a polynomial. This right here. Oh, hopefully I don't circle anything else. Okay. This right here is the basic structure of a polynomial. This doesn't have to be x squared. I wrote up here so you guys can see that a polynomial is any set of numbers in a function or equation or a relation that it goes x to the power of n plus bx to the power of 9 minus 1. And it doesn't even nearly exactly have to be like that, because b could be 0. But you'll most likely have a string of numbers like that, right? That's a good way to identify it. It's pretty much just whatever you'll be seeing in the future. You're just going to see polynomials constantly. Welcome to math and welcome to STEM. But you want to get this concept drilled into your head, especially if you want to go into higher level math courses, that a polynomial is always going to be structured as a times x to the power of whatever, n, right, plus b times x to the power of n minus 1. And then you'll go down until you're out and n equals 0. Then it will be just plus c. C could also be 0, obviously. Any one of these numbers could be. But that c is very important because it's going to be a constant. It will be set to a exact value. It could be 11, it could be 2, it could be any real numbers or any complex numbers. So with that in mind, a lot of formulas use these structures. You probably even recognize this and seen this before, using it for a quadratic formula in Algebra 1 or 2. But this is a little bit different. Actually, the quadratic formula was derived from completing the square. So the only rules for using completing the square method is a has to equal 1. The leading coefficient of the polynomial, aka a, has to equal 1. It cannot equal negative 1, which is a very common misconception. Because as this is a polynomial, negative x, right, aka negative 1 times x, you cannot have that negative sign there, or any other integer. It has to be 1. So if you have like 2x squared, you're going to have to factor out 2, and I'll get into detail on how to do that in a different video. But I want you guys to start getting used to seeing this concept, especially if you're going to watch me do this. I use this concept all the time, right? And it's very important, especially when you start dealing with functions and you want to get them to standard forms and etc., or find the zeros or whatever. So basically how this is going to work out and how you're going to apply it is that you want to add b over 2 to the power of 2 into this function. Or if you want to see it like this, whatever way makes you more comfortable with it, 2 to the power of 2. That's the same thing. These are equivalents right here. And you'll want to add that into the equation. But the first thing that you want to do is that if c is a non-zero integer, you'll want to move it to the other side. And you guys know how to do that. You need to make that integer, c, negative number, swap it over to that side, so it'd be negative c, and then you want to add b over 2 squared to both sides. And by doing that, you'll notice that b over 2 and a, in this whole polynomial, have a relation. Because since this is squared and this is squared, right, what you will get from this, and you can simplify it down immediately, is x plus b over 2. and all that's squared. And then you can FOIL it out. You guys can see for yourself, but that is this equation in a simplified way. And then the goal of this is that you can do this, solve this side, and then you can just take the square root of both sides, and then boom, you have x plus b over 2 equals the square root of some integer. Well, c minus b over 2 squared. But it'll make it a lot easier because then you can just do b over 2 plus or minus that square root. I'll show you guys how to do that right here. I set up this little polynomial already for us to solve. I already set it to 0 for you so that we can just break it down easily. I made sure this was a simpler one for us to do. But actually, I don't think I did make it simpler. But it'll be a great example of how functional this is and how much easier it is to use. So the first thing you want to do is you want to do x squared plus 2x equals positive 4, since that's already a negative 4. Because remember, subtraction sign is just a plus sign with a negative integer afterwards. So it is x squared plus 2x equals 4. And then what you want to do is x squared plus 2x. Oh my gosh. Oh, that was ugly. That was bad. Guys, close your eyes. Please don't look. This is embarrassing. Okay. Delete that. 2x plus 2 over 2 squared. And of course, you to square a fraction, you just move the power that's raised to each individual integer in the denominator and the numerator, and then you square those two, and then you just simplify the fraction, which in this example will be 1, but I will get to that in just a second. Actually, I'm not going to write that out again. I'll just do plus 1, right? So then we have x squared plus 2x plus 1 equals 5. And the beauty of this right here is that you can simplify this very quickly and very easily, and it makes your life so much easier. So I'm going to delete this. Go ahead and take a picture, I guess. I don't know. That's what my professor always says. Just take x plus 1, put them in parentheses, squared. And that is a simplified version. Much easier for you to digest. And this is why I love math. You can just, it's putty in your hands. You can do whatever you want as long as you obey the rules, and there's a very few rules. So we can turn something ugly and messy like this into just this. And then it's just equal to 5. So what does that mean for us exactly? What do we do from here? Because a lot of you guys who are just coming out of algebra, getting ready for college, and maybe just taking a sneak peek at what you're going to be looking at, might be a little overwhelmed, right? But it's really not bad at all. It's just you take the square root of both sides. X plus 1 squared. And remember, square root's always to the root of 2. Set that to the square root of 5, or equal to the square root of 5, which is also just 2, right? So equal to both sides. And then you just cross this out, cross that out. And then you just get the square root of 5. And I'll write this over here since I have more room over here. So then you just have x plus 1. And since it's on its own, it doesn't need parentheses anymore. Is equal to square root of 5. And remember, whenever you do square roots, you need to add a plus or minus to this side. Since, you know, it could be anything in there. We're not 100% sure. And then look at that. It's so easy at that point. Then you just do, and then you just move over, you subtract 1 from both sides, and then it just becomes x is equal to negative, I'll remember that, don't worry, I'm getting there, guys. I'm just a little slow. Negative 1 plus or minus square root of 5. Boom, easy, right? And there was a lot of math here, right? I deleted a lot of it, so, you know, it might be hard to remember that. But, like, at the same time, it's just following the simple steps that are given to you. It looks like a lot, but you just need to put in reps, get practice in on it, and it will be So easy for you to understand. I love this way so much more because it leaves no guesswork involved. All right, I will close the screen out and I'm going to show you guys the applications of this and show you what to do for closed functions. Functions where you can't mess with the right side of the equation. You can only deal with this stuff, and I'll show you that in just a second. All right, guys, look at that production value. Crazy, dude. I was able to do that all in post. Just kidding. I was not. You guys see I'm using Microsoft Paint right now. I don't have any money. But, okay, back to reality, though. Back to my pretend roll to math. Okay, so sometimes you'll have an equation like this. Kind of ignore this, I guess. I didn't really think about that beforehand. But sometimes you'll have an f of x function for a polynomial, right? And then you can't mess with the right side because f of x, that means y, right? And you want to keep the y on its own on the other side, right? So what do you do if you need to get it into that compact factored form so you can read it better, right? Or see it better, or whatever you need, right? Then what you need to do is you need to add in b squared over 2, right? But we don't want to change the equation, so then we immediately subtract it out of the same problem. It may look like we're like cheating here, but we're not, because this helps us a lot to just like, it just negates all what we changed to this function. So it is still the same function. It still equals the same, right? You can prove this super easily, right? It's just, it doesn't change anything. You just add it and subtract it. So it looks crazy, but it's very simple. So for this example, right, what we're going to do is, like, since we added it in, we don't want to just immediately annihilate it, right? But what we want to do is we want to grab the x and then just do what we know, right? Do b over 2, and then put that in its factor state. And then it is just, we can swap it around so it's a little bit prettier. C minus b over 2 squared. And I'll just do it this way. But yeah, so it's just like that, right? Super simple, gets in a factor form. But you guys may be asking, why do we need to do this, right? Well, when you're dealing with graphs, which you will a lot for the rest of your life, I'm sorry that I'm the one that have to inform you this, you'll be seeing a lot of parabolas and that sort of stuff. This is actually the standard form for a parabola right here. You see? Your math teacher wasn't lying to you. This actually does have a use. Well, okay, maybe not in the real world, but for future classes, it has a use, right? So this is us getting this polynomial into the standard form of a parabola, right? And you guys may be wondering, what does that mean entirely, right? So a parabola is shaped like this, but imagine that's over the origin, but whatever. I don't know. I'm working out in my basement right now. Imagine that's going over the origin. It's totally normal, right? Except for that would just be an equation x squared and the function of x squared. So that's what that is, right? But you can shift it, right? You can shift it around. I'll go into great detail about that coming soon here. But you can shift it around. And you can actually shift it to the left by b over 2 squared, or b over 2, right there. Because the vertex of the parabola, which is this point right here, the very like apex of it, where its tangent line goes to 0, it's turning, right? It's the turning point of the function. When that happens, that is called the vertex. And the vertex is represented by hk on a grid, right? Because you guys know what a grid is, I hope to God. Or else, what are you guys doing watching this? This is not helpful for you. H of k, right? And the standard form of a parabola, or yeah, standard form for a parabola equation, right, is x minus h squared plus k. So we don't need to plug in a bunch of numbers to know where this lies, right? We already know that the parabola lies at b over 2, and its y coordinate is ugly, c minus b squared over 4, because 2 squared is 4, right? And that's where its vertex is. And then even from that, we can derive more, right? Because since this is standard form, it doesn't have a negative, so we know the axis of symmetry is b over 2. And all these other, useful things. But we know that it's shifted left by b over 2 because it's an additive sign when it's the actual standard form is a negative sign. And that it is doing something up and down. I don't know. It matters on if b over 4 is greater than c. But you know what I mean. You're catching what I'm laying down here. So let me show you guys a real world example, right, where we can actually graph this. And I'll make this very easy and pretty, hopefully, if I remember what easy and pretty looks like. That's the greatest point of this. Plus, yeah, let's just do this. 2x minus 1. Alright, then we get x squared plus 2x plus 1, because 2 over 2 squared is 4 over 4. And that just equals 1. Right? So plus 1, minus 1, minus 1. Right? And then we can compact this down. X plus 1 squared. And then that's doing numbers. Negative 1 plus negative 1 equals minus 2. And then if we graph this, I'm not going to do it so pretty. I can barely write with the mouse. We'll see that H and K are both negative 1 and negative 2. So if we did this, oh god, they're getting more and more parallel. If we did this, okay, that's as much as we need. Oh no, I went the wrong way. So then we just go over 1, negative 2. We don't see a negative sign on that polynomial, so here's the origin. There's no negative sign here, so that's the proper standard form. It's going to face the same direction, and it'll look something like this. All right? And we just can derive that just straight from that problem. And then since, we know it's facing up as normal parabolas do, and it's not mirrored over the x-axis at all, which it would be with a negative sign, but luckily this is just a positive, so we don't need to do any of that gymnastics. And it's not going to be mirrored over the y-axis since the whole thing isn't negative. The x itself isn't negative. We know that the axis of symmetry is just right over the negative 1. So axis of symmetry is also just x equals negative 1, right? We can derive all that just from doing a completeness square. That's the real world applications for doing it while it's closed. Otherwise, it just helps you find roots of a polynomial. And I'll go into greater depth about that in the next video. Thank you again, guys, for listening to these videos. I know some of this stuff might be very basic, and plus with an organic chemistry teacher out, that he has a much better production value. He's way smarter than me, but I'm just hoping to help you guys out just a little bit for maybe those guys that don't understand exactly what he's talking about, and just learning my way instead. All right, thank you. Bye.